Hello guys, welcome back. In this video we're going to implement a function to delete a node with a given key or a given value. This operation basically deletes the first node in the linked list having a certain key or a value. It involves searching the linked list for the node, then it follows the same step as delete at a given position. Say the user wants to delete a node having number 40. What we will do, we will start traversing over the linked list until we have not found the node having the target value, or until we don't find the target value and we reach end of the linked list. We keep traversing. If we have duplicate values in our linked list, say here we have another node having value 40, then this function is going to delete only the first occurrence of the node having the target value or the target key. So for that, again, we are going to maintain two pointers. Let's call it temp pointer to indicate the current pointer, or using this temp pointer we will traverse over the linked list. Initially it's going to point to the head node. We will also have a previous pointer to follow the temp node. Initially it points to null. Then each time we increment the temp pointer, before we increment we are going to set the previous pointer point to temp, then we will increment the temp pointer. We also check while incrementing until we haven't reached end of the linked list, or we haven't found the node having the target value. We keep looping. So let's jump into IDE and write code for this directly. I'm gonna define a function. Let's call it public void delete by key or by value. This is going to accept a key. The first thing we are going to do, we'll check if our list is empty. If is empty, we cannot delete. We prompt the user the list is empty, cannot delete, just return. Then we are going to check if the user want to delete from the beginning of the linked list. So we just call our delete from the beginning function. What we are going to do, we'll just have the head pointer point to the next node or the second node. So let's do that before traversing over the linked list. If special case, deleting from the beginning of the linked list, if the head node having the data or the key, if head dot data equal to key. So we just want to have the head pointer point to the head dot next, head equal to head dot next, point to the second node. Again, after deleting the first node, if we have only one item or one node in our linked list, since we have also maintained a tail pointer, say we have only one node, number 10, both tail and head pointing to this one node. After deleting this node, head will point to null. We need to make the tail pointer point to null also. This is the special case if we have only one node in our linked list. Let's take care of that. So after deleting, we again gonna check if is empty or if head equal to null. Then we say this dot tail equal to null, or this dot tail equal to this dot head. This is our special case. Once we delete it, then we are going to decrement our linked list size and return. If this is not the case, we are going to maintain two pointers, a node previous pointer or prev equal to null, and we maintain a current pointer or temp pointer to traverse over the linked list. Let's call it temp equal to head initially. Using while loop, we check until we haven't reached end of the linked list, while temp not equal to null. We don't want to set temp dot next because it will not check for the last node, not equal to null. At the same time, we check if the temp pointer does not contain the key value. If temp dot data is not equal to key, we keep traversing. Before we increment the temp pointer, we have the previous pointer point to the temp. We say prev equal to temp, then temp equal to temp dot next. Once we exited out of the loop, either we reach end of the linked list and we didn't find the key, or we found the key and we exited the linked list, the while loop. we again gonna check if we reach end of the linked list and we didn't find the value by saying if temp equal to null, means we didn't find, we just want to prompt the user item or key not found and return. Else we have found the value, say we found the value at this node, this is going to be temp, and in the previous node we have a pointer previous. So using this pointer we can have the prev.next point to this node by saying prev.next, which is this pointer, equal to temp.next, temp.next, which is the memory address of this node. We will break or detach this connection, and this target node is going to be eligible for garbage collection. So we can delete the target node by saying prev.next equal to temp.next or prev.next.next. Then we are going to decrement our len. Again, we are going to check if the node deleted is the last node or the tail node. Say we deleted this node having a number 50 instead of 40. If we delete this node, we need to update our tail pointer, make it point to the second last node. So let's check that corner case also. We check if we looped and found the value at this position, so temp is going to point here. We check if temp is equal to null, we just will make temp point to the previous. In that case, we'll have previous here and temp here. So we will make temp tail point to the previous node. So let's do that. If temp equal to tail, if the item to be deleted is the last node, we just want to say tail equal to this dot tail equal to previous pointer, and that's it. Let's check our function. Go to the main function. Say I want to list dot delete by key. Say I want to delete number 10 from the beginning of the linked list. 10 is gone. We have 20, 30, 40. Say I want to delete number 30. 30 is gone. Size is decremented. Say I want to delete from the end of the linked list. 50 is gone. If I want to search or delete for an item which is not present in the linked list, item not found. Thank you guys for watching, and see you in the next video. Bye bye.